ever imagine a world where like AI teams could not only solve complex problems but learn from their experiences
Yeah.
and improve their strategies just like a well-oiled human team would?
Uh-huh.
That's what we're diving into today.
Okay.
We're unpacking a cutting-edge research paper called Reflective Multi-Agent Collaboration Based on Large Language Models.
Wow.
It's a deep dive into how teams of AI,
Right.
powered by large language models or LLMs, can collaborate and learn from each other.
So what's really exciting here
Yeah.
is that these AI teams aren't just a theoretical concept anymore.
Right.
We're seeing them being applied in real-world scenarios,
Yeah.
from tackling scientific questions to simulating complex systems like economic activity.
That's right. The paper specifically mentions using these AI teams for world simulations in fields like economics and policymaking.
Exactly.
But before we get ahead of ourselves, let's break down what an LLM-powered team actually is.
Right. So it's essentially a group of AI agents, each with its own specific skills and expertise, coming together to achieve a shared goal. It's like assembling a dream team of AI specialists, each bringing their unique abilities to the table.
So instead of just having one AI trying to solve everything,
Right.
we have a team of specialized AI working together.
Yeah.
That makes a lot of sense. But what really sets this research apart is the idea of reflection.
Hmm.
These AI agents don't just stop at giving answers, they actually analyze their performance
Oh, interesting.
and learn from their mistakes.
Exactly. They can look back on a task,
Yeah.
figure out where they succeeded, where they stumbled,
Right.
and then use that information to adjust their strategies for the future.
Yeah.
This ability to reflect and adapt
Yeah.
is what makes these AI teams truly special.
It's like they have their own built-in continuous improvement program.
Yeah.
But how do they actually do this reflecting?
Right.
Is there like a mini AI coach giving them pep talks and pointing out areas for improvement?
Oh, not quite pep talks, but the researchers introduce a fascinating framework called COPPER, which stands for Counterfactual PPO Enhanced Shared Reflector.
Gotcha.
It's a mouthful, I know,
Yeah.
but it's basically a method to train a shared reflector
Right.
that acts as a central feedback mechanism for the whole team.
Okay, so we've got this shared reflector acting like a coach,
Right.
but how does it figure out which agent deserves the gold star and which one needs to hit the practice field?
Right.
That's going to be tricky with a whole team of AI contributing.
That's a key challenge called the credit assignment problem.
Okay.
In a team setting, it's hard to isolate individual contributions to overall success or failure.
Yeah.
Think of it like trying to figure out which player on a basketball team was truly responsible for winning the game.
Yeah,
It's a complex web of interactions.
that makes sense. So how does Copper deal with this challenge? Does it just give everyone a participation trophy?
Not at all. Copper employs a clever technique called counterfactual rewards.
Interesting.
Imagine removing one player from that basketball game and seeing how the outcome changes. That's essentially what Copper does. It runs simulations where it removes one agent's contribution at a time
Wow.
to see how that impacts the overall result.
That's so smart. So by simulating these what-if scenarios, Copper can pinpoint each agent's unique value to the team.
Right.
It's like rewinding the game tape and saying,
Exactly.
okay, let's see what happens if we take this player out of the equation.
Exactly. This provides incredibly precise and personalized feedback for each agent, helping them understand where they shined and where they could improve.
So each agent gets their own personalized report card based on these simulations.
Exactly.
Pretty high-tech coaching. But tell me more about this shared reflector.
Sure.
Why is it shared rather than giving each agent its own individual reflector?
Well, it turns out that using a single shared reflector model actually improves the stability of the training process
Okay.
and makes it more efficient.
So it's like having one super coach who understands the strengths and weaknesses of the entire team, rather than a bunch of individual coaches working in silos. Makes sense.
Yeah.
But how does this shared reflector give tailored feedback if it's coaching the whole team at once?
That's where the individual profiles of each agent come in.
Okay.
The shared reflector is fed information about each agent's role, constraints, and specific expertise. This allows it to tailor its feedback and guidance based on each agent's unique situation.
It's like the coach having detailed files on each player,
Yeah.
allowing them to provide specific advice, even though they're addressing the whole team. Pretty impressive. But the real question is, does this actually work?
Right.
Does this whole Copper framework with its shared reflector and counterfactual rewards actually improve the performance of these AI teams? Like,
Right.
is this all just theory, or does it actually translate into better results?
That's a great question. That's what we'll dive into next.
Awesome. Can't wait.
Yeah, that's where the researchers really put copper to the test. They used 3 diverse data sets to see how well these AI teams performed with the help of this reflective framework. Think of it like giving these AI teams a series of challenges to test their skills.
Okay, bring on the AI Olympics. What were these data sets? What kind of challenges did they pose?
First up was HotPotQA, a data set focused on multi-hop question answering. This means the AI teams had to sift through a lot of information and combine different pieces of knowledge to answer complex questions. It's like being a superpowered detective piecing together clues from various sources.
Sounds challenging. What was the second data set?
The second challenge was GSM-8K, which is a collection of grade school math problems. While these problems may seem simple to us humans, they require logical reasoning and step-by-step problem-solving skills, which can be tricky for AI.
So we're testing both their knowledge and their reasoning skills. What was the final challenge in this AI decathlon?
The last dataset was Checkmate, in one move, a chess dataset. This one really tests strategic thinking and the ability to plan ahead. The AI teams had to analyze the chessboard and find the single move that would lead to checkmate. Talk about pressure.
So we've got trivia, math, and chess, a pretty diverse set of challenges. How did our AI teams with their fancy shared reflector perform against these tests?
They absolutely crushed it. Copper consistently outperformed other methods across all 3 datasets, showing that this reflective learning approach really does lead to some serious improvements.
That's impressive. Do we have any specific numbers to show just how much of a difference this reflective learning makes?
Absolutely. Here's one that really highlights the power of copper on the Checkmate and one move dataset. Copper achieved an 86.4% improvement over methods that didn't use reflection. That's nearly double the performance.
Wow, that's a game changer. Clearly, reflection isn't just some feel-good exercise for these AI teams. It's a crucial ingredient for achieving significant performance gains. But this isn't just about building AI that can ace trivia or solve math problems, right? What are the bigger implications of this research? Where else could this technology make a real impact?
That's what gets me really excited. The potential applications are incredibly broad. Imagine self-driving cars that can not only navigate roads, but also analyze their driving decisions, learn from near misses, and constantly improve their safety protocols.
That would be incredible. It would be like having a car that gets smarter and safer with every mile it drives. What other fields come to mind?
This technology could revolutionize scientific discovery. Picture teams of AI agents working together to analyze massive data sets, identify hidden patterns, and generate new hypotheses. It would be like having a team of tireless research assistants accelerating the pace of scientific breakthroughs.
It sounds like this could change the way we approach research and problem solving in countless fields. But let's be realistic for a moment. If this technology is so groundbreaking, why haven't we seen it widely adopted yet? Are there still hurdles to overcome?
Of course, like any cutting-edge technology, there are challenges to address before we see widespread adoption. One key hurdle is the computational cost. These AI models require a lot of processing power to run all those simulations and learn effectively.
So even brilliant AI needs a lot of horsepower to flex its mental muscles. What other challenges are researchers working on?
Another key area is developing more sophisticated memory structures for these AI agents. Remember, these agents need to store and retrieve their experiences to learn effectively. Current approaches rely on relatively simple memory mechanisms, but we need more advanced models that can truly capture the nuances and complexities of their learning journey.
It's like upgrading the AI's hard drive to handle all that complex learning data. Are there any other challenges on the horizon?
Designing effective training environments is another critical area. Remember, these AI agents learn through interaction and feedback. Creating realistic and engaging training environments that provide meaningful feedback is a complex task.
It's like building a virtual training ground where these AI teams can hone their skills and push their boundaries. But it sounds like researchers are tackling these challenges head on. I'm curious, what specific applications are you most excited to see in the future?
One area with immense potential is personalized education. Imagine AI tutors that can adapt to each student's unique learning style, provide tailored feedback, and create personalized learning paths.
So instead of one-size-fits-all classrooms, we could have education tailored to each student's strengths and needs. That's truly revolutionary. What else has you buzzing with excitement?
The possibilities are endless. Think about healthcare AI agents assisting doctors with diagnoses, analyzing medical images, and even personalizing treatment plans. Or imagine them helping us design smarter and more sustainable cities, optimizing traffic flow and resource management.
It feels like we're on the cusp of a new era of AI-powered innovation. But before we get carried away by all the amazing possibilities, let's take a moment to consider the potential downsides. We've all seen those sci-fi movies where AI takes over the world. Are there any real ethical concerns we need to address as this technology develops? It's true those sci-fi scenarios can make you wonder about the unintended consequences of powerful technology, but focusing on the positive, the fact that these AI agents can actually reflect on their actions, seems like a built-in safety mechanism. It's not just about blind intelligence, it's about AI that can analyze its own decisions.
That's a really important point. This reflective capability is crucial for developing AI that aligns with human values and goals by designing AI that can consider the consequences of its actions. We can create systems that are not only intelligent, but also ethical and responsible.
So instead of just worrying about AI going rogue, we can focus on building AI that's inherently thoughtful and considerate. It sounds like this reflective ability is key to shaping a positive future with AI.
Absolutely, and it's not just about preventing negative outcomes. Reflection can also help AI become more creative and innovative. Imagine AI agents that can not only solve problems, but also reflect on different approaches, identify areas for improvement, and come up with entirely new solutions.
It's like AI going from being a student to becoming a true innovator, pushing the boundaries of what's possible. But let's bring it back down to earth for a moment for our listeners who might be feeling a bit overwhelmed by all this talk of AI teams and shared reflectors. What's the one key takeaway you want them to remember from this deep dive?
I'd say the most important takeaway is the future of AI isn't just about building bigger and faster algorithms. It's about creating systems that can learn, adapt, and collaborate effectively. This research into reflective AI teams is a glimpse into that future, a future where AI doesn't just solve problems, but also understands, learns, and evolves alongside us.
That's a really powerful message. It's not just about AI replacing humans, it's about AI and humans working together, each bringing their unique strengths to the table. It's about teamwork learning and continuous improvement, whether you're an AI agent or a human being.
Well said, and I think that's a perfect note to end on. It's been a pleasure diving into this fascinating research with you.
A huge thank you to our expert for guiding us through the world of reflective AI teams. It's been an eye-opening journey into the future of AI, and hopefully our listeners are feeling just as inspired as I am.
Remember, the future of AI is shaped by the questions we ask and the choices we make today. So keep exploring, keep learning, and keep asking those big questions.
And that's the takeaway from this deep dive into reflective multi-agent collaboration. We'll see you next time on the deep dive.